Good morning everyone. Today's our topic is resistance. Okay, so what is resistance? It is the hindrance to the flow of current. So we have done already in physics also according to Ohm's law in 10th class. Okay, what is Ohm's law? Ohm's law is I is equal to V by R, or you can say V is equal to IR. Okay, so this relation only written here, but we have to do in chemistry only the numerical related to current or resistance. Okay, so next topic it is conductance. So what is conductance? It is the property of material by virtue of which it favors the flow of current. Okay, if current will flow, then it result into the conductance of that material. Okay, so we can represent it is by using G. Okay, and G means conductance. It is inversely proportional to resistance. So what is the unit of resistance? Resistance unit, it is ohm. Then what is the unit of conductance? It is ohms inverse, or you can say Simon. Okay, ohm inverse, it is called Simon also. So you can see here specific resistance, that is also called resistivity, which is represented by rho. So already we have done in 10th class in physics, R is equal to rho L by A. Okay, so what is rho here? It is the resistivity. Okay, and what is L? It is the length, and A, it is the area. So but we have to do here according to chemistry only. Okay, so length, it is not the length of the wire, it is the length of the two rods having a area A. Okay, the space between two rods that you will take now, that is the L. Okay, so how much area it will occupy? That is A. So by using this formula you can solve the numerical. Next term it is given here, specific conductance. It is inverse of resistivity. So whatever value you will get of resistivity, inverse if you will do, then you will get the conductivity. Okay, same formula we are using here. So you can see specific conductance is equal to conductance into cell constant. What is cell constant here? L by A. Why it is kept here constant? Because whenever you want to solve the value of conductance, then you have to take the beaker in which two rods are kept always at the same length. Okay, and in a particular area. So we have kept the length or area, it is constant. That's why L by A, it is called cell constant. Okay, so you can see here by using this relation here, R is equal to rho L by A given. L by A, it is called cell constant. Okay, so in terms of conductance also you can write specific conductance is equal to conductance into cell constant. R is equal to rho L by A. Rho you can write na 1 by small k. Okay, that is kappa you can say, and it is the conductivity, specific conductance, that is inverse of that one. Okay, R you can write 1 by C or 1 by G, means that is conductance. So by using this relation only we have got this value. Okay, specific conductance is equal to conductance into cell constant. This value, it is cell constant. So unit you have to learn. Okay, next it is called molar conductivity or molar conductance. How you can represent molar conductivity? By lambda. Okay, at any concentration you can use the C, or without C also you can write here. So molar conductivity or molar conductance, it is equal to K into 1000 by M. Okay, so how much volume you have taken here? Actually it is K into V, and that V is equal to 1000 by M. Okay, how much volume that contain 1 gram equivalent, that is equal to V. You can kept here. Okay. So you can write here molar conductivity is equal to K into 1000 by M. In the same way, equivalent conductivity you can solve, that is represented by EQ K into V, where V it is 1000 by N. Okay, equivalent word, whenever it will come, you have to use the normality. Molar will come, then you have to use the molarity. But you have to take care, it is taken at any concentration, it is not at infinite dilution. So this relation you have to learn for solving the numerical. Next, you can see here the numerical. One normality solution of salts surrounding two platinum electrodes 2.1 centimeter apart means two rods. It is separated by how much centimeter? 2.1 centimeter. Okay, 4.2 square centimeter means how much area it is there? 4.2. Was found to offer a resistance of 50 ohm. Calculate the equivalent conductivity of the solution. So what you have to solve? Equivalent conductivity, that is represented by lambda EQ. Yes, now our next topic it is determination of molar conductivity at infinite dilution. Okay, this graph it is given to you, it is very important in board point of view, it is coming many times. Okay, so you can see here what does this graph shows here. You can see here it is the graph between molar conductivity at infinite dilution with related to concentration. Okay, if you will move from left to right, the concentration will increase, but if you will move from right to left, then concentration will decrease and it approaches to zero value. Okay, if concentration will decrease and it will reaches to zero value, then you can say here na, it will occur at infinite dilution, where concentration will be zero, then dilution will be there. Okay, so you have to take the point that you are using at infinite dilution. Okay, so graph it is plotted for strong electrolyte and weak electrolyte. You can see at the starting point for strong electrolyte it is upper side and for weak it is downside. Okay, why it is kept upside? Because if you will see strong electrolyte, it will dissociate completely, it means it has strong conductance as compared to weak electrolyte. Okay, it is having more conducting power as compared to weak, that's why this point it is given upside. But if you will move from right to left, okay, then what will happen? You are doing the dilution, and during dilution conductance will increase. Here you can see here in strong electrolyte, suppose you have taken 10 molecules of AB, then all ions it is already dissociated into 10 A positive and 10 B negative. Then on dilution, why the conductance will increase? Because it is not because of decomposition or breaking, you can say it is because of separation between the two ions. It means there is no interionic resistance. Okay, so on dilution two ions separate from each other and there is no interionic attraction. As a result of this, conductance will increases. Okay, so during dilution conductance will increases, but if you will see here in a weak electrolyte, the point it is kept down as compared to strong, because in a weak electrolyte if you will take the 10 molecules, then you will get only the 6. It is assumed value only, it means it is not a 10, it is less than 10. 6 ions of A positive and 6 ions of B negative you will get here, then remaining parts it will remain undissociated. Okay, so not dissociated completely, that's why the conductance will be less, that's why its value will be downside. But if you will increase the dilution, okay, on dilution, you can say on dilution, then these ions will break further. Okay, then number of ions will increase, as well as the interionic attraction also increases. Okay, so that's why there is a large difference between the 2 points of weak electrolytes. This area it is more as compared to strong electrolyte, this one. Okay, if you will see the initial point and final, then this difference it is less as compared to weak electrolyte. Okay, why? Because in strong electrolyte only the one condition is responsible, that is the interionic separation. But in a weak electrolyte there are two conditions, means two factors are responsible for the conductance. One is to difference means no interionic attraction, as well as the formation of large number of ions on dilution, means you can say increase in number of ions. So this graph it is very important, you have to do. There is average large increase in conductance with dilution, especially near infinite dilution. As concentration of weak electrolyte is reduced, more of it's ionized. Okay, so same thing it is given here. But you can see in this graph, if you will extrapolate the graph for strong electrolyte, it will cross the line, okay, of molar conductance at infinite dilution. If this graph, this vertical line it will cross, you can say na, for strong electrolyte you can get the value of molar conductance. But for weak electrolyte, if you will extrapolate this, it will not cross the value, it will not cross the y-axis. It means it will not give the molar conductance at infinite dilution. Infinite dilution means you have to cross this value, then only you will get any point on this line. Okay, in weak electrolyte we are not getting, but in strong electrolyte we are getting this value. So you can say na, with the help of graph we can solve the value of molar conductivity at infinite dilution. But for weak electrolyte we are not able to solve the value of molar conductance at infinite dilution. Okay, so after that only Colrat's law came, that we one numerical we have done yesterday already. Okay, we have done. So Colrat's law it is applicable only for a weak electrolyte. So Colrat's used the value of strong. By using a strong electrolyte that we have solved with the help of graph, we can solve for a weak electrolyte. Okay. So Debye-Hacker-Onsager equation, this value it is given. Molar conductance at any concentration is equal to molar conductance at infinite minus B root C. Okay, B it is constant and C is the concentration. Why they have plotted the graph under root by taking this value under root C? Because this value will give the smaller value. Okay, by using a smaller value we can easily solve conductance at infinite dilution. Okay, because it will reduce the value and answer you will get accordingly. So the reason it is given here, non-linearity of a curve in case of weak electrolyte shoots up suddenly for some low concentration, assumes the shape of straight line parallel to molar conductance axis. Okay, we have seen the value means if you will extrapolate, it will go parallel to the graph, it will not cross the line of y-axis. Okay, hence extrapolation in this case is impossible. Experimentally also the value of molar conductance at infinite for weak electrolyte cannot be determined, we can't determine. Okay, so for that only Colrat's law came. So what is Colrat's law? It is the law for independent migration of ion at infinite dilution when dissociation is complete. Okay, every ion makes some definite contribution towards the molar conductance. Okay, if number of ions will be found more and more, then it will means contribute to the molar conductance of electrolyte. Okay, regardless of the nature of other ions which with it is associated, does not depends other ions present near to it. Okay, and that the molar conductance at infinite dilution for any electrolyte. Okay, so by using Colrat's you can solve the molar conductance at infinite dilution for a weak electrolyte. So one example it is given here, how you can solve. If you want to solve the acetic acid, molar conductance for acetic acid, so first you have to dissociate into two ions. This part is negative and this part is positive. H positive it is present in HCl, CH3CO present in sodium acetate. So what you don't need, chlorine and sodium, that you have to subtract NaCl. So all values it will be given to you with the help of graph. That value you can use and you can solve the value of acetic acid. Okay. So determination of degree of dissociation, alpha, how you can solve? Number of molecules ionized divided by total number of molecules dissolved. Okay. So alpha is equal to molar conductance at any concentration divided by molar conductance at infinite dilution. So we have already done all these formulas. Determination for solubility of sparingly soluble salt. Okay. Molar conductance at infinite dilution. Solubility you can measure in terms of at infinite dilution only. Same formula we are using here. 1000 K into by 1000 into K. What is K here? It is specific conductance. C is the concentration. So accordingly you can solve. C, it can be molarity or normality. So few questions it is given to you. Compare the conductance in the following: Cl3C, CH2, COH, CH3, CH2COOH. Okay, what is the name of this compound? How many carbons are present here? 3. Then it is called propanoic acid, and this is the substituted compound. Okay, this hydrogen, it is substituted with chlorine. Okay, so you have to compare the conductance. So conductance power of A, it is more as compared to B. Okay, why? If you will see here, in which case ionic means which one behaves as a more ionic compound? A. Okay, because chlorine, it is negatively charged and remaining part it will be the positive. Okay, so more number of ions will be formed in part of A only. So degree of dissociation in case of A, it is more as compared to degree of dissociation as compared to B. So more than degree of dissociation means more dissociation will be there, then more will be the conductance. So one numerical it is given to you related to solubility. Calculate the solubility product of barium sulfate if its conductivity and molar conductance at saturation are given these values. Okay, so first you have to dissociate barium sulfate into two parts, barium ion and sulfate ion. Okay, so solubility of these two, it is represented in the form of S. Okay, so KSP you can write here, it is S square solubility product. Okay, because how many ions are formed here? 2 ions. Okay, so solubility of these two, it is considered to be S and S. So KSP, it is S square. Okay, so we have done already this formula. Molar conductance at infinite dilution is equal to K into 1000 by concentration. This concentration, it is given in terms of solubility. You can write here solubility also. So S will come here and this value will come down. You will get this formula. Okay, so you can see here molar conductance, it is given to you 153 for this compound. Okay, and K value, it is given to you 3.06 into 10 to the power minus 6. You can put here, then value of S you can solve. So after calculation of S, if you will get the value of S, you can solve the KSP. Okay, so final answer you will get 4 into 10 to the power minus 10. Okay, so one numerical also given to you on the basis of Colrat's law. We have already done. Okay, you need to solve for the acetic acid. Okay, that is CH3COOH. How you can solve? By taking the value of CH3COOH, COO and H positive ion. Okay, all values given to you for sodium chloride, hydrochloric acid and sodium acetate. So you have to add the hydrochloric acid and sodium acetate and subtract sodium chloride. Okay, so finally you will get the answer 390.7. So in next lecture we will do factor affecting electrolytic conductance.